Hi everyone. In today's session, we are going to see about multi-threading models and the operating systems. Multi-threading. Most applications nowadays are multi-threaded. Threads run within an application. Multiple tasks within the application can be implemented using separate threads. For example, such as uh, update of an display and fetching the data from the memory location and spell checking and answering the network request, whatever. These are the few examples. All these tasks can be simultaneously run on the system. In this, each task is considered to be run as a thread. So in this given example, 4 tasks are allocated. So 4 tasks will initiate 4 individual threads and 4 threads will be running on the processor simultaneously. This is the concept of multi-threading. That is, n number of tasks can be executed simultaneously. In this, the process creation is considered to be as heavyweight, while thread creation is considered as less weight compared to process creation. In this, a simple code is more efficient, and it increases the efficiency of the process using the concept of multi-threadings. All these kernels are generally multi-threaded. This is the multi-threaded server architecture. In this, whenever the clients request and process to the server creates an thread for initiating the request, and it's open for any other request which is initiated by other clients. This is the architecture for implementation of multi-threaded server. What is the benefit of multi-threading? There are basically 4 benefits of multi-threading. It is nothing but responsiveness is very high, may allow continuous execution if the part of the process is blocked, especially important to the user interface. That is nothing but if a process which is involved in execution is getting blocked, the other process will give their responses. So the complete shutdown of the process can be avoided using multi-threading. Next one is resource sharing. In this, these threads which is created will be sharing the same resources for the process, and this communication can be implemented using cooperating process, implementation of IPC, inter-process communication, basically of 2 types, which is of shared memory and message passing. We have already seen the implementation of IPC in previous sessions. And the third benefit is nothing but economy. That is, the as I said, the process creation is compared to be heavier than thread creation. So this is thread is comparatively cheaper than process creation, and the thread switch over is comparatively lower than context switching of process. The process communication, the data switching should be shared between all other process, that is known as context switching. The data will be shared among one or more process, and this thread switching is comparatively lower than process context switching. And the finally fourth one is scalability. A process can take advantage of multi-processor architecture, so the scalability is much more compared to single threaded process than multi-threaded process. Okay, these are the 4 benefits of implementation of multi-threading. Here, let us see. Here, this is it. This is the diagram which implementation of single threaded and multi-threaded process. Single threaded is nothing but it will have initiated only one thread, and that individual request will be processed. But simultaneously in multi-threading, more than one thread can be executed simultaneously by the processor. And this is the advantage of multi-threading process.